Whoa, it's working! Yes! BMP388 is working. B status. Whoa, it's working! Yes! That's working too. Awesome. So the only component which is missing is...
Alright, what's up everyone? Hope you guys doing well. This is Karthik Rangarajan, founder and CEO of Agam Robotics. I wanted to share with you guys some of the latest developments and testing I've been going through. I'll share the mistakes I made in the process. If you have followed me on Twitter, I've been sharing some of the updates. If you haven't, make sure you follow and get the updates. So a month ago, I received the sensor board, which is like the second board which has like Agam Robotics name and logo in it. And this is the flex cable, which is going to connect like the sensor board and the flight controller. So it sends all the information from the sensor board to the flight controller through this cable here. The sensor board is the third board in the flight stack you see here. The carrier board is the bottom, there's the flight controller in the middle, and on the top is the sensor board, which is connected through the flex cable. The sensor board consists of like two IMUs, one barometer and one magnetometer, and there's like one EEPROM for like saving the sensor calibrated data. And there's also like a simple heater circuit to warm up the entire board. So the two IMUs are like the 6-axis accelerometer and gyroscope, 3 axes for each, and barometer is like the pressure sensor. Magnetometer is like a 3-axis magnetometer sensor, which measures like the magnetic field in 3 axes, like X, Y, and Z. The flight controller already has like an IMU and barometer, so the IMU and barometer on the sensor board is sort of like a redundant system. The reason or like the purpose is that like the entire board is like soft mounted, which eliminates the vibrations from the drone, like from the motors and like the propeller, which causes like the entire vibration of the drone. And this eliminates the soft mounting eliminates that sort of vibration and gets a clean data from the sensors to the flight control algorithm. And this sort of like makes the correct decisions. So these sensors are like communicating on I2C protocol. It's one of the protocol which is typically used in these devices. Like you might have seen like the optical flow sensor in our previous video used SPI protocol. So these are like two multiple different protocols what is being used. So what happens here in this case is that like each of these sensors run on different buses and has like different addresses assigned to it. This is where I made the mistake in the design. The flight controller, which already has IMU and barometer, which I mentioned, is like running with a default addresses. And I designed the same sensor board with the same default addresses, which is actually, like the data gets merged when the algorithm tries to like process that information, which is actually wrong. Like it has its own addresses where it needs to be fed to. So this is where I had to go back to like modifying the PCBs, like because we already have the prototyping boards. I didn't want to like order a new one before like making sure the sensor and like this board, every design is like working well. I've done like bigger modifications, like modifying traces and like replacing or repairing a pad damages board, but those were like pretty big ones. This one is like super tiny board. Like this is like the first time I'm doing such a process. So let's get right into it. All right, as you can see here, I've made some modifications already, and actually I did not want to put those videos here because I actually made a mistake. The top trace was not supposed to be cut. I actually looked at the design I made and chose the wrong trace and made a modification already. So I'm like trying to rework on that here. I didn't want to like take another board and do it. I just wanted to like use what has been already sort of like not damaged, but already modified it. So I just wanted to like do all the modifications on this board, and if some major damages happen, like I'll be taking a pretty new board again. But hopefully that didn't happen in this case. I've like made modifications on one single board here. have used like IPA alcohol, which is used for like cleaning the PCBs. So the pink trace is where I actually made a mistake. I'm like supposed to swap yellow and red together. I'll try to speeden up the process here. It's all like just modifications. You can like slow down and watch it if you need it. It's all like super fun to watch, and it's like 100x super fun to like modify these boards. So once the trace has been modified, it needs to be soldered. So since it's exposed copper, you can add like a bit of solder and it immediately catches on. And since in this case, like two of those traces needs to be reversed, I've already shorted those pin and it's been cut already. So this one is like the fully completed modified traces here, and you can see the short ones and also the mistake I've made and the reverse which needs to be done. So once after cleaning, this is just to make sure there are like no flux residue anywhere. I use like IPA, isopropyl alcohol, to like clean up the surfaces. And then we'll like proceed with checking if there's any short and the connections are like made correctly. So these two traces needs to be connected, and you hear the beep. And these two should not be connected, so there's like no continuity. There is a continuity here, it's all good. And there's no continuity between those two paths, that's good. And this is the trace where I was not supposed to modify, and that's also been repaired, so there's all like continuity there. Double checking, so it's all good. So the next, the component is on the other side. So this is the barometer. The address needs to be changed for this one, where one of the pad is connected to the ground, but it needs to be connected to the voltage. So that's where the modification is. And because the pad is like the ground pad and it's connected to the ground plane, the entire plane here is like ground. It's this was like a really tough soldering process. So the next in the list, or like the next modification, is the EEPROM. The resistor where it's connected to needs to be cut, and then that needs to be connected to a voltage. So we'll proceed with like the trace modification and then wiring to the voltage. All right, that looks all good. It's connected, and this is the complete board after like the modification, and it's sort of like ready for testing.
All right, it's time to test the board. Plugging in, you can see the board with all the wire modifications here. That's it. Connecting for the first time, so there's like no magic smoke. I guess it should all be good. Right, it's plugged in, it's connected. Let's go to Maveling console. So I got to test BMP388 status. Whoa, it's working! Yes! BMP388 is working. BMI, I think BMI 088 status. This was already working. Yes, you could see it's connected on the SPI bus 3. And let's test the gyro to make sure, okay, it's all good. So those two components are good. ICM 42688P status. Whoa, it's working. Yes! That's working too. Awesome. So the only component which is missing is BMM150. I choose C detect. Let's test the EEPROM too. I have to see detect B4. B3. Oh my god, that's both the things are working. Awesome.
Okay, so now that it's working, what now? What's the next stage? So most of the components are working in the board, and the one which is not working, or like one we haven't modified yet, is the magnetometer. And because it has it's a component called BGA, so there's like it's ball grid array, so they're like soldering balls on the bottom of the component, and it's like really hard to modify because the track is right underneath the component. So it's like really hard. I'll like show you the video, you can look into it. So the problem here is like it's the only way to modify or do the modification here is like remove the component, like desolder it, and make the modifications on the trace, and then like place the component back. It sounds easy, but the problem is if it's a pad, it can be done. And because it's a BGA, the moment you desolder it, the balls are going to get damaged, and you need to do reballing to the component. And the reballing process is like a really complicated task. And to do that manually, and because it's a small component, it can be done manually, but you won't get the same ball size available. So I've like already checked with my repair guy, like he's already looking into it. So if that works, we'll be like trying to modify this and replace it. Okay, so now that it's almost like all the sensors are working, can we like test it? Like, can we like not just make sure it's like getting detected, but can we test the sensor? Yes, we can, but the problem is because you've seen like all the modifications, the interferences are more. There's like higher chances that the wires could be. All right, I don't know what happened in there. Like as I was editing, I found that the video is okay, but the audio was like completely garbled. So it was like none of the footage could have been like salvaged. I'm not sure like what happened at the end. Probably I think it got like the GPU was like overloaded or something. But anyways, what I was saying is that like the wire modifications could cause like a lot of interference with the sensor, and that could sort of like deviate the actual sensor data to like completely with a lot of errors and like more interferences from these wires. So basically the plan is to modify the design and get a new boards manufactured. Probably I'm expecting like a express manufacturing fabrication process, like 3 to 4 days, or like less than like 5 days, I would say. Get the boards manufactured and get the components from these boards to the new board, and then like make sure like everything's working, get the right data, and then place it on the drone and fly it. So that's basically the plan for now. I'll keep you guys posted. As of now, that's the process I'm going to work on. If there's anything, like comment down below if you want to like see anything apart from these designs what I've worked on. See you guys in the next video. Thank you.